Question number 27. Two parallel wires X and Y carry the same current. Okay. There is a repulsive force per unit length F on each wire. So when can the force be repulsive? When you have one current like this, other current like this, definitely there will be a repulsive force. Okay. This is known to us. The direction of the current in each wire is reversed. Now this is your situation A. The situation B is that this current which is going like this, you made it like this. Okay. This current which is coming like this, you made it like this. This is the situation. Okay, the current in X is doubled. Current in X, let me call this as X, this is Y over here. So this is X, Y over here. Now the current here, let us say this is I, and here this became 2I. This became 2I. And he doesn't say anything over here. Let me say I1, let me say I2 here. So this is 2I1 over here, and in I2 nothing is changing. And the current in Y remains the same. So I have the same one over here. The separation of X and Y is also doubled. I wrote much nearby. Maybe it should have been much larger. This was where D, this becomes 2D. What is the magnitude and direction of the force per unit length on each one? The force per unit length F is given by the formula mu naught I1 I2 divided by 2 pi into D, where mu naught is your permeability of free space. Now the first case, what happens? So the same formula holds good. The second case, when this changes, what will happen? F dash is equal to mu naught into what is I1. I1 I am going to replace with 2I1, and I2 remains the same. Divided by 2 pi, and what happens to D? D is replaced by 2D over here. So this D and this 2 goes away. So once again I get mu naught I1 I2 divided by 2 pi D. So which is the answer correct here? These two are incorrect. One of them should be correct. Okay. Now the next one. So one of them should be correct. Let us look at this one. Now what is happening to the direction? See, he said that the current is there. The direction of the current in each wire is reversed. It's not only one wire. Both the wires. In this case, if it was going upwards, it's downwards. Here it is going downwards, it's going upwards. Once again, you see the currents are moving in opposite direction. There will be a repulsive force, right? It will not be an attractive force. Attractive force will come only when two currents are moving in the same direction. Okay, and repulsive force would be, so this is your attractive force. Repulsive force would be when it is like this, the repulsive force, the opposite direction. So here also it is opposite direction. So therefore, repulsive here. So the option here is